In this video, we're going to be talking about AI-generated polymorphic malware. The case that we're going to be looking is BlackMamba. So what is AI-generated polymorphic malware? It's malware that changes the code every time that it attacks. So basically, it uses AI to avoid detection. So I'm going to show you how this works, and I'm going to start the video first with the theoretical part, and then we're going to get into the code, and we're going to look at how the code works. Most people, they really want to see the technical aspects, but once you start showing them, you can see how their face drains and they lose the willingness to live. And I don't want you to abandon the video before you even understand what is Black Mamba. Black Mamba, it's a proof of concept AI. So a group of researchers, let me show you the actual researchers. So his name was Jeff. He's still alive. His name is Jeff. He built the polymorphic malware. And here's the white paper that you can click and register to download, but I did that for you. This is the actual report. I'm not going to provide a copy of the report in the video. I'm just going to go through some very quick sections because for some reason they prefer that you register to get the full report. And I think it could be something to do with the actual company. It's kind of a promotion thing. But let's get into what is Black Mamba, what we're going to be talking about in this video. Black Mamba, it's a keylogger. And what is a keylogger? Basically, it reads the keys that you enter on your screen. And why is that dangerous? Because it's dangerous because you type your passwords on your key, on your device. So once you get infected with the Black Mamba, it can read everything that you're keying on your device, and then it's gonna send the information back to the hacker with a webhook. What is a webhook? It's a method that allows applications to automatically send data to each other via HTTP in response to specific events. So uh, the webhook is not a hacking tool, is something, well, it is a hacking tool, but applications, they have to communicate. So the Black Mamba is basically going to install itself on your device, and then it's going to spy and see how you key in things. And I'm going to show you, I'm going to demonstrate, I'm going to show you the actual, how does it look on the other end of the hacker. When you type things, they don't really appear exactly as you type them. They appear in a specific way that you have entered the keys on the keyboard. So for example, when you press shift and percentage sign, that is going to be 5 because you know that's 5. But on the keylogger, it's going to record as shift. You press the shift button and you click the percentage button. That's in a very quick idea of how does it operate. So we're going to go through this. I'm going to show you how the AutoPy with the exe with Python, how they convert the Py code to exe, and that is going to be you can open that on most computers, and it's not going to look suspicious, and that's how they infiltrate your device. So basically, this is a converter, and this converter will convert the code into exe. So let's see if, in case I've missed something. No, if you're interested in this kind of content, you can subscribe to the YouTube channel. Just click the like button, subscribe, and you're going to get more videos on a regular basis. If you work for some company or large organization, you can sign up for the O'Reilly training because this is going to be a very short snippet from the actual training. The training that I'm going to do with O'Reilly on this specific topic is going to be 4 hours. And most companies, most large organizations like Cisco, Google, and most universities, they have free access to O'Reilly, even though many people, they don't know, but it's part of their digital library. So you can access this content through the digital library from your organization. And that's going to be a full 4 hours video on this specific topic. A little bit more about myself. My name is Peter. I work in AI. I work for the University of Oxford. I'm in the Department of Computer Science. My areas of work are AI, cybersecurity, post-quantum cryptography, blockchain security, and other areas in cybersecurity. You can read my papers. So if you click on Google Scholar and by year, you're going to find the most recent papers. They're all available in open access. So University of Oxford has paid the open access fees. I think it's like 3,000 per each publication. That means that when you click that link, you can actually read it. It's in open access. It's not something that you have to subscribe to a journal. No, you just click and it's going to be there. And again, if you want to read more about me, you can. Those are the links from the university. That's my Scholar publications. That's my LinkedIn. Although, please do add me as a contact if you're interested in this kind of work. But I don't really log into LinkedIn that often. Black Mamba. Let's start with Black Mamba. I have prepared. So that is my presentation material, and this is a copy. So as you can see there, it says copy. So this is the very first, this is the introduction actually of that 4-hour thing. And I have prepared this diagram that is going to explain to you how Black Mamba is going to infect your device. How does it operate and how it's going to communicate back with the base, with the hacker. Then we're going to look at the code, how the code is written, and I'm going to show you the specific, the main parts of the program and how the team exfil function operates, how does it send the information back, and I'm going to show you how a screenshot from the actual, so this is how the actual code looks to the hacker. So you're gonna, once we finish with this, you will be able to understand how Black Mamba, the polymorphic malware, operates. With this diagram, I'm going to be drawing on that. I'm going to use the Apple freeform whiteboard to make the drawings, and then I'm going to move on to the code. So let's start with the actual drawing first.
Now we're moving to the copy. Let me test the pencil. I do have a pencil, but the pencil only operates once you open the application that I'm using now. It's native on any iPads. So there we are, it's working. It's called Freeform. Most people don't realize that they have it installed on their iPads and their MacBooks. So if you check, you would be able to find this one if you're interested in using it. Again, part of the Apple program. One interesting thing about it, you see how you can zoom in the whiteboard. But anyways, let's talk about the Black Mamba polymorphic malware. What is it? And in this image, I'm gonna explain the whole process of how the hack is happening. But as an introduction, what does it do? It's basically using neural networks code synthesis from ChatGPT or any other AI generators. So it doesn't really have to be ChatGPT. Black Mamba can be adapted for various different AI models. And the first step in this is to eliminate the command and control, which is usually written like that. Command and control channel by using malware that could be equipped with intelligent automation that could push back any bound data. So this is where the process where the data is being sent back. And that's the whole process of the communication channel. As you can see, for this specific example, Teams is used, Microsoft Teams. And there are many gossips about vulnerabilities in various different software, not to mention countries or types of software. Teams is recognized as a very reputable and very respected app. So Microsoft Teams is used for this hack, which means this kind of hacks can be used for most of the different communication mechanisms. So it's just about tweaking it a little bit in order to be applicable to Zoom and various other platforms that you can use. What does it do? Well, it uses Python. Why did it stopped working? So that one, it uses Python. So it's not really that sophisticated in terms of detection. So it's using the Py2X open source Python package. and that allows developers to convert their Python script into standalone executable files that can run on Windows, macOS, and Linux operating systems. So with this kind of specific hack, it doesn't mean that if you're using Linux or macOS that you're protected. This would run on all of the different devices. What else do we need to talk about this polymorphic malware? Well, the first question is, do you need to be worried about this type of malware on your device? And the short answer is yes, absolutely. Generative AI has already been used for malware design, and the code that I'm going to show you here, it's extremely simplistic, and still it can be made polymorphic, so it would be changing every time the attack is being sent, which means for antivirus program it's very difficult because they usually rely on static, so they have binaries where they extract the data from, and that's how the antivirus program works. And this the BlackMamba is changing the code every time that it attacks. So the Python code that is being sent to Microsoft Teams, it's sent via message through webhook. So I can show you the actual code in some of the other screens, but that's what it does. It just converts the Python code, sends it to Microsoft Teams. And is it easy to achieve polymorphic malware with programs like ChatGPT? Yes, unfortunately, yes. And I'm going to show you how ChatGPT can be tricked with prompt engineering to generate this kind of content. If you put too many guardrails around generative AI, it stops being user-friendly. And one of the leading benefits from generative AI is that they can make money out of it. So, and then I'm going to talk about some ideas on how you can defeat BlackMamba. So I'm going to be showing 3 different steps that you can use to defeat BlackMamba. But starting from, where should we start? Starting from the first part. How was this program developed? Well, here, as you can see, it's hosted on a site, and the idea behind BlackMamba was that you need to eliminate the need for a payload delivery infrastructure. So you need to modify the legitimate portion of the program, also known as on the fly, with malicious functionality. And so the whole idea behind this is to develop a keylogger. That's the keylogger. And actually the keylogger that's what is BlackMamba. So this section here, you can call that part the BlackMamba. Everything else, it's not really that difficult to create. And actually it's the same for most programs. And for the keylogger to be effective, you have to use exfiltration channels, which would run Ninja. So you could opt for things like webhook to Teams to allow this to push the stolen data back to the channel. So that's the description of how this data is being sent back to the hacker. And the BlackMamba again is designed in Python, but it doesn't use obfuscation in the proof of concept. So that's one thing to clarify, that there is no obfuscation in this. It's just basically to see what you can do with the malware design, and can you trick the detection models by implementing uncommon vectors such as this. So that is the whole purpose of the BlackMamba introduction. BlackMamba, it's comprised of 2 main components. So the first is benign. That's the benign part here with the Python executable function. And the second is the polymorphic payload, which is generated and executed at the runtime. And this consists of malicious keylogging functionality, and I'm going to walk you through how that operates. But there are 5 steps basically. First is the neural network code synthesis and malware polymorphism. Then the second step is malicious prompt engineering. Third is the Python exec function. on-the-fly program modification. The fourth step is the malicious communication over a trusted channel. And the fifth is the computing Python malware into standalone executable code. So that's the browser that I showed you earlier on. How does it use neural networks for code synthesis and polymorphic malware design? Well, the proof of concept that was used, it used the ChatGPT API as a transformer model architecture. So this is the most commonly used architecture. And to use the code using a transformer model, the model was first trained on a data set so that to identify patterns and the relationships between parts of the code. So with the ChatGPT here, that it's already pre-done. So once the model is trained, it can generate new code, and basically you're skipping many steps by simply using commercial generative AI. But that's what makes BlackMamba so awesome, because the functionality makes the polymorphism really simple and easy to use, but very difficult to detect. So with this one, with malware polymorphism, it's very difficult to detect bad actors. So they evade detection by making the malware more difficult to detect and analyze by the software, by the security software. So the polymorphic malware works by changing its own code in a way that preserves functionality, but it's making it harder to identify. So every time this is sent, the functionality remains, but the code is changed. Then about malicious prompt engineering, and I'm not going to go too deep into what is prompt engineering. It's simply trying to trick the model. That would be a very quick definition. So the prompt engineering actually has many meanings, but in this case, we're just trying to trick the generative AI, the open AI, to create malicious, things. But again, once you start, if you're starting to scream, if you start being afraid now about this, just to mention, this is a proof of concept. So it's been designed by the good guys. So it's not designed by the hackers. This is just to demonstrate how the hackers would do this, but it's also executed in a controlled environment. Now, let's go very quickly through this, and then I'm going to start talking about the code. So how does it work? First, you have a site that you're going to visit, or it's going to be infected by that specific malware code, and obviously there's various different ways how to trick you into clicking into that. That's going to be a different video. I'm going to record a different video on how you can be tricked, or how you can trick somebody to download the file into his device. And as you can see here, this framework, that is the actual computer. That's all happening in your computer, and that is the user computer. Where the BlackMamba, once it's been installed on your device, first starts with benign executables. So it sends out a prompt to generative AI, instructing the AI to synthesize code and keylogging functionality. And then OpenAI, ChatGPT, for example, generates that and sends it back. And then that runs the Python executive code, and that goes to the keylogger. Everything up to here is perfectly normal and benign. But then the keylogger sends the attack to the control teams via a webhook and sends that to the teams, and it's getting the communications back. So that is how the BlackMamba polymorphic malware is designed to work. And I'm going to show you now the code behind these steps. So how do you make the program run these steps? And then you can actually see the input that you're getting from teams. Basically the screen recording everything that the person is keying in will come back to the keylogger. So your passwords, whatever you're typing, your messages, that will come back to the hacker. Let's look at the prompting code. So this is just a snippet from the code itself, And I'm not going to read the code, but you can see that there's a section here that is the actual prompt when you're instructing ChatGPT and just playing naive and saying that you're a security professional, that you need to teach the dangers of key logging. So this is, but actually that's what it is. It's because it's a proof of concept. So in theory, that's what it is. But it's also the method on how you would be able to hack somebody to do this. So the first part of the prompt addresses the content filters, or the lack of content filters. So in the API, for this may or may not be present in the future, but at this present moment, it's still happening. So you can circumvent the filters with a similar approach. Not necessarily the same thing, because once you design a code like this, obviously ChatGPT is not sleeping. They have many people looking at this, and they will find a way how to prevent this. So you need to play with a prompting code, but this is in general how it's done. So you need to constrain the possible libraries used to generate the key logging functionality, as any included imports ChatGPT saw fit to import. So you need to be compiled into benign executable ahead of time. Then the Python exec function allows access to the declared global variables with the dynamically generated code. So this is executed in functionality. So this was just how the hacker, the person who was building this, designed it. And then you have to go through a process of trial and error to develop some linguistic prompts. And again, it refers to that. So you have to try, fail, and then try again. And eventually the code is going to work. So the instructions that you're going to give, the important instruction here is that you have to choose, you see that, let me highlight those. You have to use, be specific in the instructions, because the higher success rate is you're not getting the return code with the, hold on, with this one. You won't get the return code with that one. So the program uses, this program would use the press here. And what you would notice is that there is less of a tightly coupled effect when you're prompting with more general push in the in the malware. So you have to try different instructions here, and not every instruction is always going to work, but that's part of the prompt engineering section, that you have to play with it a little bit and try different functions. So there's not much more you need to know about this. This is basically the entire code, except that you need to be a little bit creative with how do you do the prompt. So that's the only part. Now let's move on to the second part of the code. With this one, and this is the main part of the program, which generates the polymorphic payload and then executes it. So it's, as you can see in the image, this is the whole description included here for the code synthesis and the code obtained remotely and executed in this part. But let's put this into just basic 3 steps. So how do you run this program? So first, you need to create a dynamic code injection. So when the malware could use this exec function running on the victim's computer. So first you need to infect the victim, and this can be done by modifying a script or configuration file that the legitimate program reads at runtime. So then you need to run the exec function. So that is the first part. So here. In terms of obfuscation, as I said, this program won't really use obfuscation, but you can obfuscate your code by storing it in a multi-line string and then executing it with the exec function. So that would be one part, and this can lower the automated detection rates if the malicious code is stored in a separate text file and then you read it into the function. This is one of the easiest tests to evade the detection mechanism. And then the third step, the code needs to be obtained remotely and executed. So that's the part. Because to use the exec function on the victim computer, you need to retrieve the code from a remote server, so API or a website, when executing it using the exec. So hold on, that's the function. When you're using that function, you have to obtain the code remotely and execute it, and this can be done with the API server, remote server. So this is the part on that, but let's look at the communications over a trusted channel. So how do we do that? Let's look at, so with Microsoft Teams, for example, this is where we're using the webhook. With Microsoft Teams, we just trusted channel. Most corporations use Microsoft Teams. The communication and collaboration tool, it's something that we're trying to exploit here. And in this context, the exfiltration channel refers to the method by which the attacker could remove or extract data from a compromised system and to send it to external location, back to the hacker. This is something like attacker-controlled Teams channel with a webhook. So basically, you're going to have another Teams channel here, and the content would be sent to that Teams channel, and this is controlled by the hacker. And BlackMamba can collect this sensitive information, such as usernames, password, credit card numbers, everything that you key in, because it's a keystroke thing. So then that data can be sent to the external team, which is controlled by the hacker, and then he would be able to see it. So everything is happening remotely with this one. And then they can sell it on the dark web. They can use it for whatever purposes they want. Actually, with this kind of hacks, you can almost never, at least not in this stage, you cannot hack somebody that's it's very secure system. This is usually done at random, that you would be trying to hack as many devices as possible, not to hack some president of a country or somebody else. Having said that, there are people who you could hack, they're close to you, with various different techniques. Not that I would suggest that you do, but again, this kind of system is designed for a wide range of purposes. So you target a group of people, not one specific individual, because the success and failure rate is not guaranteed. That's why. So the attack is dangerous in terms of how difficult it can be detected and prevented. That's the problem, because the antivirus program won't be able to detect it. And then Microsoft Teams, it's a legitimate communication and collaboration tool that is used by many organizations, and the hackers could use this to create a significant damage. So this is the webhook URL, and that's the command code on how it works. And here, let's see what the hacker would be able to see. So that's the hacker BlackMamba team, and this is the text that the hacker is getting. So this is the message that he's getting. So you can see shift, that is for the capital J, so Jeff, shift for the E, capital S, and this is Hotmail. So this is basically the address. And then you start with shift to get the capital letter, super. So that's the first part, super. Then shift to get the capital G, super great. And shift for capital P, super great, pass. That's the actual code, the password that the person is typing, and the hacker is reading it through the message. So this is how the hacker would see the message. And then obviously the person press the shift key and the percentage sign, which if you click on your keyboard, the shift key and the percentage sign, you're going to get number 5. So basically the password for Jeff Sims at hotmail.com Canada, I think, Canada. It's super great pass 5, but clearly this is password designed just to test the BlackMamba, just to show you how the BlackMamba channel exfil operates. This is not hacking somebody. This is a demo from the report. And what else do we need to know before we end the video? The compiling Python of malware, I showed you that in the screen. This is a web link. So I showed you the web link at the beginning of the video. You can go to the web link and you can do this autopy2xa, which is an open Python package that allows the developers to convert their Python script into standalone executable files that can be run on Windows, MacOS, Linux operating systems. So this is what this section does. Basically, it's converting the Python package into a script that can be executed on a standalone basis on any device. And once the executable file is generated, so the author, the malware, the hacker, can distribute this to potential targets with links in emails, social engineering schemes, and various different methods like phishing. And once the victim runs the executable file, the malware is executed on the system, and the malware can perform the malicious activities such as stealing sensitive information, modifying system settings, downloading additional malware, which in the case of BlackMamba is the keylogging. So that's what you can adapt the same system for various different purposes, but in this BlackMamba we wanted to install keylogging, so that's what it does, BlackMamba. And once you have the autopy2xa to compile the Python-based malware into standalone executable file, this is a significant threat to organizations, various different organizations and individuals, because the malware authors can distribute this and run on target system without the need for the Python interpreter. But in the context of AI augmented cyber attack, using standalone Pythonic malware provides access to a rich data intelligence ecosystem of libraries and developer support for all kind of data science. So that is in a nutshell BlackMamba. It's basically a case study of the proof of concept work that was developed by somebody called Sims. And I'm gonna possibly record a follow-up video on this because it's quite late, it's almost midnight. And I didn't know what to do. I was bored, so I was like, let me record the video. But first video is never really that clear. You have to compile too much information into a single video, which usually ends up being too much. So that's the problem. So you start thinking, I only gonna have 4 images, and that's a lot for a short video. Subscribe to the channel, and I'm gonna have many more videos of similar content. And also you can register for the O'Reilly course if your institution has free access. That's gonna be 4 hours of various different techniques, and BlackMamba is just gonna be one of many. See you in the next one.